This recording is to again help you with LV02.2K. This time I'm focusing in on part B of question 1. State 3 reasons why the exhaust system is mounted to the vehicle body by flexible mounts. Now, I did mention to you guys that I tried to make a video of a oscillating ruler. Here it is. I couldn't upload it previously, but I'll just run this for you. And hopefully you can see the idea is that the longer the exhaust is, the more it's going to vibrate and more noise it will make. And I did find another video on YouTube. Just run this one. This will just prove the point that exhausts do vibrate. Just have a look at this. Fantastic bit of vibration on a Jaguar exhaust there. Alright, so the longer that exhaust pipe is, the more it's going to oscillate or vibrate. And obviously you can see that, you know, it needs to be secured, otherwise you're going to have that awful rattle. And the other thing about exhaust pipes is they get very hot. So just to prove that, I know you know that, but just to prove that. So exhaust pipes get very hot. So really, the reason we're using rubber mounts or rubber hangers is to insulate or isolate the exhaust from the bodywork to prevent vibrations, noise, and heat being transferred into the bodywork. All right, so that should help you answer that question 1 part B. Let's go back to the questions, and now I want to focus in on part C. Alright, there we go. State the 2 types of silencers used in modern vehicle exhaust systems and how each type reduces exhaust gas noise. Now, when you look at this on the internet, there are lots more than just 2 types of silencers, because there are lots of variations on a similar theme. But what we're after here is the 2 main categories, if you like. Now, to understand this, we need to look at what sound is. Now, sound, this GIF here shows that sound is a waveform. It's energy, vibrations through the air, traveling through the air. So when I speak, my lungs are pumping out air through my vocal cords, which makes the air vibrate, and the part of your eardrum that senses those vibrations converts that to a signal for your brain so you can understand what I'm saying. So what this GIF is showing is that whatever's creating the sound, so in our case an exhaust or an engine that's running and then pushing that vibrating air through the exhaust pipe, the sound is coming in a waveform. Now, 3 things are actually going to happen. All right, some of that sound energy is going to actually transmit through the exhaust pipe, the wall of the exhaust pipe. So some sound will come out, all right, but you can see that there's, what this GIF is trying to show you is that there's a lot of energy here and less energy gets through. So it's going to be quieter, just the fact that we've got it inside an exhaust pipe. Now, some of the sound energy will be reflected. Now, that's what you and I might think of as an echo. So you can see the waveform of the energy. It hits the side of the exhaust pipe and bounces off and is reflected sound. Now, we'll come back to that in a minute. But the other thing that's going to go on is that some of that sound energy is absorbed in. Now, we've got an absorbent material here. Could be if it wasn't an exhaust, it could be some foam or whatever, and you know that foam deadens sound. All right, now what's happening is that sound energy is going into the material that makes up this sound deadening, and it's making all the particles in here kind of vibrate, and it's actually converting that sound energy to heat energy. So effectively, the energy or the sound is absorbed into that material. So three things go on. Some of it gets through and is transmitted, but obviously will be reduced energy, so it's quieter. Some of it will be absorbed and converted to heat energy, and some of it will be reflected. Now, this reflection is interesting because it's going the opposite way, it has an effect of cancelling out some of this sound. So I'm going to show you another slide here. Okay, now this slide here shows what this is meant to be is a speaker that's bouncing backwards and forwards, making the air vibrate, and here's somebody's ear that can detect that sound. And we know, I'm sure you've heard of people talking about sound travelling as a waveform. So it's an increase in pressure. All right, as the speaker moves, it compresses the air slightly and then moves backwards, and so we've got increases and decreases in pressure, or making the air pulsate or vibrate. So we've got an increase in pressure and a decrease in pressure, and it's the what they call the amplitude, the height of this waveform, how much pressure difference there is, that determines how loud the sound is. Okay, so it's the difference between this point and this point will determine how loud that sound is. Now, if we get the sound to bounce back, let me just go backwards just to remind you. If we get it to hit a wall and bounce back, then they're still going to vibrate here. But let me just move on to the next slide after this. Okay, so we're talking of what we call phasing of sound. And up here you can see my, the original sound wave. So we're talking about peak to trough. How deep that is determines how much, or the amount of sound, how loud it is. And this is what we're showing here is that waveform bouncing backwards, but they're slightly out of sync now. So in reality, can you see that the sound is going to drop from here down to this point and then come back up, and then only drops down to this point? So we've reduced the height from here to here, and it's now, in this case, it's only from here to here, and then in this one it's from here to here, so it's slightly reduced. So this would have the effect of cancelling the sound slightly, making it slightly quieter. And here we've got them completely out of phase, so now the sound is only going from here to halfway down. So effectively the sound would only be half as loud. Now I found a video online that kind of proves it, and I'm going to show you that in a moment. Now what the guy does, he sets up a speaker, makes one speaker make a sound, and then he's got two speakers next to each other, so he then energizes both of them, and you can hear the sound is almost twice as loud, and then he moves one slightly backwards, and so has the effect of putting them out of phase, and you'll see what impact that has. Okay, I'm going to play that video and then I'll come back to you.
Okay, so what I've done is I've set up two identical speakers at the same distance from the camera, and they're both hooked up to an amplifier and to the signal generator. What I'm going to do is turn on the primary speaker. Now you can hear the sound coming from just one speaker. If I hook up the second speaker in phase with the first, you'll hear that the sound level gets louder. And that makes sense because you have twice the amount of sound energy hitting the camera. If I then take one of the speakers and begin moving it back toward half a wavelength apart, you'll hear that the sound progressively gets quieter and quieter and quieter. And this is because they're out of phase with spacing.
Okay, so now you've got an understanding of how you can reduce the level of noise by creating an echo, if you like, within a chamber. In other words, making that sound wave bounce backwards but be out of phase. Okay, so this is one of my drawings. I'm going to draw the exhaust pipe. There's the silencer. Bear with me, you'll kind of see what I'm trying to draw, I think, in a moment. Okay, so there's my silencer in an exhaust pipe. So my exhaust gases come in this side from the engine, and they're going to flow into this large expanse, the silencer, and as they come into this they expand. So this is an expansion chamber, and as a consequence they sort of bounce around and they're going to end up bouncing back into each other. Now, as the energy that they carry collides with each other, they end up, to a certain extent, cancelling each other out. So it kind of reduces the noise energy. Okay, hopefully that explains the capacity type or resonator type exhaust system. So this slide shows a capacity type, or sometimes it's called a resonator. I don't mind if you use resonator or capacity type. The terminology means the same thing. But in this one, the exhaust gases are coming from the engine into the inlet. They're going to flow through this section of pipe, and at this point it's got perforations, little holes in the pipe, and so some of the gas will come out and some of it will travel through and come out at this end, and then it's forced to turn around and come back and bounce backwards and forwards all over the place. So it creates that echo, if you like, and helps to cancel out some of the noise energy. Eventually it will find its way back into this pipe or cross into the perforations, and then it can get out through the outlet. But in this section it's going to, as I say, bounce backwards and forwards and lose or cancel out some of that sound energy and reduces the noise. The other type is sound deadening. You know, I mentioned earlier that we could use foam backing if it was in our house to reduce noise. So inside this exhaust you can see this is actually fiberglass. So very, very fine strands of glass that are so fine they almost look like cotton. So it kind of almost is like cotton wool, but it's fiberglass. And as the exhaust gases come in, the noise energy, sorry, let's go back. The noise energy comes through these holes and it hits these fibres and makes them vibrate, and in doing so it converts that noise energy to heat energy, and so deadens some of the noise. The next couple of slides, sorry, are a combination of both types. So absorption and capacity are the two types of exhaust silencer. Now in this one you can see the noisy vibrating gases are going in, and you can see they're sort of redirected and forced to bounce into each other, so they cancel out some of that energy. So that's the capacity or resonator type. But there's also some absorption material in this section here that's going to absorb some of that sound energy. So this is a combination of both types. Obviously it's a diagram, but here we've got an actual exhaust silencer that's been cut open. You can see the top has been cut off with an angle grinder, and in this one if we assume that the gases are coming in from the engine through this way, to be honest I'm not sure if that's right, but it kind of works. And what's going to happen, the gases are going to come in through to this part here, they're going to bounce about backwards and forwards, but here just inside you can just about make out some it's packed with the glass fibre. So this area here is going to be an absorbent mat. So these gases that have lots of sound energy will hit that, bounce backwards and forwards. This will absorb some of the sound energy. The rest of it will then pass through, which you can't see, but there's a hollow like an access point here. It's going to go into this chamber, again bounce backwards and forwards, and those sound waves will collide into each other and so cancel out some of the noise. There's also another absorbent mat over this side. You can see the glass fibres, the sort of packed into this space. So again that deadens some of the sound, absorbs some of that sound energy, and then eventually those gases that have lost lots and lots of their sound energy will then pass out and be much quieter. Okay, hopefully that helps you answer both the or name and explain the two types of silencer. We've got a capacity type, or sometimes known as a resonator, so capacity resonator type, and the other type is the absorption type. In America they call it a muffler because it muffles the sound. Okay, hopefully that will help you answer those two parts of the question. I'm going to sign out now.